Okay, horizontal stretches and shrinks and vertical stretches and shrinks these are the non-rigid transformations that we have. And so what's going to happen is if I have a function, whoops, if I have a function like this, I have x plus 1 in parentheses, I'm squaring it, this is my function. If I want to do a horizontal stretch of 2, then what I'm going to have to do is think about what f of x over 2 is. Okay, that's going to be a horizontal stretch of 2. So I would have to plug in x over 2 right here, which x over 2 is the same as 1 half x. Okay, and that's what my function would be. But if I want to vertically stretch this function, then what I'm doing, like if I want to vertically stretch it by 3, then it's going to be on the outside of my function being multiplied. So it'll be outside of my parentheses here. Okay, so if it's something that's inside that's going on that's affecting my x, then what I care about is if it's got a fraction, what the bottom of the fraction is. If it's a whole number, it'll be the reciprocal. So a stretch is going to be something that's greater than 1. So I stretched this by 2, which gave me a 2 on the bottom. A shrink is if I had like 1 half. If I put 1 half on the bottom, the reciprocal of that's going to make that a 2x. Vertical stretches I find a lot easier personally, that you have that you're multiplying by 3, so it's going to stretch it by 3. If you multiply it by like 1 half, it's a shrink of a factor of 1 half. So let's try an example. On this problem, it says let C1 be the curve defined by y1 equals f of x equals x cubed minus 16x. Find the following equations. On part A, we have C2 is a vertical stretch of C1 by a factor of 3. Okay, so this is going to be kind of similar to what I just did on the previous slide. For C2, I am vertically stretching by 3, so I'm saying 3 times what f of x is. Okay, well, what is f of x? It's x cubed minus 16x. So if I times that by 3, make sure you put parentheses so that you distribute. That is what my vertical stretch is going to look like. And if I simplify that, it'd be 3x cubed minus whatever 3 times 16 is, 48, minus 48x. Okay, so this is my function C2. For part B, I have a horizontal shrink on C1 by a factor of 1 half. So C3 is my original function where I'm taking x and I am dividing it by my factor of c, which is 1 half. Well, what is that the same of it? Same as if I have x over 1 half, I can flip the 1 half up and I'm really doing f of 2x. So what I can do is I can plug the 2x into my function where x is. Like a so. And then I would simplify this. 2 cubed is 8, x cubed is x cubed. Negative 16 times 2x is negative 32x. So that would be C3. So that's 8x cubed minus 32x. Let me try not to circle over the 8. There we go. Okay, so let's look at combining these different transformations. For example 6, I'm going to find the equation of the graph of y equals x squared if it undergoes the following transformations in order. So in order is important there because we could end up with two different things if we're not going in the order that they're giving us. So y equals x squared, or more than two things actually. I want to do a horizontal shift of 2 units to the right. Well, horizontal shifts are going to go inside parentheses, and so 2 units to the right is minus 2. Then I have the squared on the outside. Now I want to do a vertical stretch of with a factor of 3, so that's going to go outside of my function, outside of my parentheses. Right, and then last, what I want to do is I want to do a vertical translation of 5 units up. So I'm going to take what I've got and I'm going to move it up 5 units, which is going to add a plus 5. Let's go ahead and work out what this is so that we can compare it to, we're going to do it the opposite way now. Well, in a sec. Okay, to do x minus 2 squared, I have to FOIL and then distribute the 3. So I get y equals 3x squared minus 12x, and then I get 3 times 4 is 12, but I want to add the 5 and get 17. So this is my function all solved out for doing these transformations in order. Now let's say I want to go backwards. Let's see what happens. If I have a vertical translation up 5 units on x squared, then that is y equals x squared plus 5. If I am taking that function that I just made and I'm vertically stretching it by 3, then that means I need parentheses with a 3 on the outside. Okay, so hopefully now you can see what, because of the order, if we do that vertical translation first, then we end up with this stretch affecting it. If we do it last, if we're talking about just having it a plus 5 on the end, that means we need to do that vertical translation last. So then if I'm going to shift 2 units to the right, then what I need to do is say that means that I still have the 3 on the outside, but now this x needs the x minus 2 to show that I'm going to the right, and I have the plus 5. So that got complicated. We already know what this part is. This is x squared minus 4x plus 4 plus 5 is still in there. We're timesing that by 3. So this right here will be 9. And then I just need to distribute my 3. So the only thing that it changed on my graph of these two things, oh, the only thing it changed is this, that we're starting our graph at 27 now instead of 17. These would be my y-intercepts for these parabolas. So what that means is if they're giving you something and they want you to graph it and they give you something that looks like this, okay, do everything but the vertical shift first. So do this part where we're shifting to the right to and do the stretch, but then after that is when you're going to do the vertical shift up. Okay, the last thing we're going to talk about is if they give us a graph and they want us to make a new graph with a transformation of it, what do we actually do? Okay, they're telling us that this is f of x, this line. Okay, this line right here is f of x. They want us to sketch the graph of 1 plus 2 times f of x minus 1. So there's 3 things going on here. We have a horizontal shift to the right one. We are doing a vertical stretch of 2. And we're also shifting up 1. Even though the one's in front instead of behind it, it's still a shift up 1. All right, so any point on here, what I'm going to do on my graph is I'm going to do those 3 things, and I'm going to do them in that order, because remember, I want to do the shift up or down last. So I'm going to move this point right here, right 1. I'm going to stretch it by 2. So this y-coordinate here is 1. If I stretch it by 2, I'm timesing by 2, which means now that's going to be right here. And then I'm going to shift up 1. So it's going to take us some points to really figure out what's going on here. So now let's look at this point. Now let's look at let's look at these points where we're changing, where we're starting and ending and changing. Okay, so this point right here, if I go right 1, that's right here. If I vertically stretch that, it was at 1, so now it's going to be at 2. Oh, I didn't mean to make that mark. It's now going to be at 2, and then I'm going to shift up 1. So this line right here, I just shifted up to here. Okay, so now this point is actually going to be off our graph, so let's do this one instead. If I have this point and I want to move it right 1, then I want to vertically stretch it 2. It's already at 2 on my y-axis, so I'm going to times that by 2, and now it's going to be at 4. And then I'm going to shift up 1, and so really it's going to be at 5, which is also off my graph, but whatever. So that line is actually, going more steeply up. For this point down here, I may or may not be on our graph, but let's talk about it. If I go right 1, and then I multiply my y value by 2, negative 3 times 2 is negative 6, which is not on my graph, it's down here. And then I shift up 1, that's at negative 5, so that would be right here. Or if I want to do a point that was closer that I know will be on my graph, I'm going to move right 1. I'm going to vertically stretch by 2, so negative 1 times 2 is negative 2. Then I'm going to shift up 1, which is right here. So you can kind of see this is going like this. I'm not very good at straight lines on this thing. So what happened is I moved it to the right. I'm also moving it up 1, and then I'm also making it to where it's going up faster and down faster than it was before. Okay, and so when you do it, there's some problems in the book that have you do those things like separately. Some of them have you do them all together, but it'll both be easier and harder because you're going to have a separate graph. You can't just say, okay, I'm literally doing this and this and this to my graph, but you just follow through what's going on here. I'm moving right 1, and I'm vertically stretching, and then I'm going to shift it up 1. Okay, so that's the end of 1.6.